Hello, good morning. Welcome to our talk. So yeah, I saw a lot of hands up for people who use Slack. We're going to talk about some methods that Slack uses to keep Slack developers safe and to safeguard people and prevent them from shooting themselves in the foot. So hence the talk title, Bulletproof Shoes. So I'm Max Feldman. I work on the product security team at Slack. I joined 3 years ago yesterday, so 3-year anniversary yesterday. Before that, I worked at Salesforce on the product security team there. At Slack, I run our bug bounty program. I work on feature reviews there, making sure that we're shipping secure code and secure features. And I also do some training initiatives. I join our DevRel tours. We have a booth here, and I help with some of our platform security measures as well. So today we're going to talk about our token nuker. So I'm going to go over the problem itself. I'm going to go over the solution that we've built, some of the future work we'll be working on, some lessons learned, and time allowing, we might have a little time for Q&A. If not, Slack has a booth here, and I'll be around the conference. So Slack. A lot of you use Slack. What is Slack? It's a hub for collaborating. So one of the big features of Slack is bringing workflows together. So integrating with other applications, it becomes kind of a hub, a central point where you can use other apps, other integrations. You can build your own tools. You can build custom integrations. You can use things like Salesforce, Google Drive, Dropbox, Box, etc. So what is a Slack app? It's a lot of different things. It could be as simple as a webhook that's posting weather information. It could be something silly. We have a lunch train app. So if you want to go get lunch with your coworkers, you can use a / command to see who else wants to get lunch. We have a custom integration out in San Francisco of which food trucks are near the office. But we also have more powerful things. We have code reviews. We run our secure development lifecycle through Slack as well. I'll talk about the token nuker itself and how it's posting into Slack. But quick question, who has used a Slack app before? Yeah, so a lot of people. You have probably seen many of them. And so where do these Slack apps come from? So we have over 200,000 developers on the Slack platform. And that's not apps. That's active developers. That's individuals who are creating apps. They may or may not be on our app directory for public use. So it may be a custom integration for your own company. You may be running doing chat ops or something like that. You may be pushing code, doing code reviews. You may be approving expense reports, etc. That could be custom. Or it could be something on our app directory. So we have over 1,500 apps in the app directory, and those are public, available to install. They're vetted for quality. We perform security assessments of these. And they're there to save you time and bring things together. So if you go on our app directory, you can see a lot of the apps that are there. And as many of you raised your hands, you've used them before. So brief architectural overview of a Slack app. So we have the Slack client. We have a Slack server. And then we have an app server. So Slack apps are not running in Slack itself. We aren't hosting code. We're providing a means for your app to integrate with Slack. So someone is using a Slack client. Maybe it's the browser. Maybe it's a mobile client. Maybe it's a desktop client. It communicates back with the Slack server, which can then send events off to your server. It can receive requests. It can receive incoming webhooks. There's communication back and forth between your app server, which may be hosted in AWS, somewhere in the cloud. Could be on-prem, depending on what you're building. So this is the high-level overview of what makes a Slack app. And so apps need tokens. So we'll talk a little bit about webhooks. But in general, a Slack app will use the OAuth 2.0 API in order to get a token, and you'll have a user authorize an app, and they'll say, OK, yes, I grant these permissions, and then your app will get a token, and it can use that to communicate back and forth with Slack. So it can post information into Slack. It can access resources. These can have different scopes, and we'll go over some of those shortly. So like I said, when you're going through the app approval process, you click approve. You can see at the very bottom is where the kind of scarier, maybe more powerful things are. And at the top will be other permissions that the app is requesting. So you can deny them or approve them. And we have a couple different kinds of tokens. So who has built a Slack app before? Or a custom integration, or worked with the Slack API? Cool, so handful of people. We have user tokens, and so these are prefixed with XOXP. These allow you to work directly on behalf of a user, so a user grants some permissions, some OAuth scopes, and then this token has those permissions. We also have bot user tokens, which are prefixed with XOXB, and these allow a bot, which is kind of a powerful pseudo-type user, not pseudo as in with an S, but with a PS. So it's kind of a user, but it's not like an all-powerful one. But it does have some additional permissions. So those are two pretty common tokens. So that brings us to the problem. Who has ever accidentally leaked a token on GitHub or Pastebin? And you don't have to raise your hand if you don't want to. That's OK. But it happens. We have people doing tests. We have users who are trying to quickly get something together, and maybe you put a credential or a token in your dot file and you upload that for people's convenience. Or you're really proud of your bash RC and you forgot that it's full of your AWS credentials or something, and you put it on GitHub and then realize, oh no, that's publicly there. So that can happen with Slack tokens as well. Maybe you've built a Slack app, you shared it, and your token is in that repo. So it sucks when you lose your keys. So if we do a quick search on GitHub, and I'm going to note that this is old. This is no longer the case, and I'm also going to explain why it's OK, because we've nuked all of these. But you can see here, if you search for just XOXP, you get about 27,000 results. And a unique aspect of this is there aren't many other things on GitHub called XOXP or XOXB, so it's kind of like high signal-to-noise ratio. But so here's an example of the top match. So someone doing a test email to check API functionality, and they put their token in that. So if you go on GitHub and you search for these things, people have done this before. There are accidental leaks of Slack tokens. And so if we do a little bit deeper dive into some of the token scopes. If you've used Slack apps, you know that they are very powerful. They can do a lot of things. So maybe they can write to a channel. Maybe they can read all of the chats in your channel. Maybe they can get history, user information. So we have more documentation on the specific scopes, but they're very powerful. So if you lose a token, you might be thinking, oh, well, who cares if some attacker can steal my token and look at my memes or look at my GIFs, et cetera. Not all Slack users are just using it for memes. There are companies, corporations, people who are using it with sensitive data. Maybe you've discussed something like corporate secrets. Maybe you've shared credentials within Slack, which we advise you not to do, but maybe you have. And so if you have an app token that's been leaked, and someone grabs that, and someone hits the Slack API and says, hey, I just want all of these channels, there's a lot of information in there that can be taken. You can also post to channels. You could potentially impersonate users, or if you steal a bot token, maybe you're the new Jenkins bot, and you say, like, hey, here's some great code. Please put this in your repo and put remote code execution in your app. So we don't want this outcome. Another well, there are a lot of powerful scopes. The admin scope can give an app the ability to administer your workspace. So it can add users, change users, et cetera, lock people out. It could completely, if in the wrong hands, these can be disastrous for your organization. So it can read audit logs, things like that, security sensitive information. And this is with the user token. The legacy token, it doesn't mean this is an API, but there's a type of Slack token called the legacy token. And so yeah, that information in your Slack workspace can be extremely not good to lose to an attacker. So you could have your credentials, which, like I said, we advise against. You could have links to company-sensitive information. You could have files uploaded. You could have pay stubs. You could have social security numbers. Maybe your HR department handles all of your hiring, firing, et cetera, and it has messages in one channel of like, oh, this person was fired for this reason, et cetera, important files. You have a lot of sensitive information in there, and the larger the organization, the more data there is. And so people make mistakes. This is not necessarily super factual, but I mean, it's a little more qualitative than quantitative, but we can kind of see over time how the search for git remove history became more common. And I think it's fair to say that this becomes more common of a problem. The ease of coding, the ease of deploying things and putting things online has grown. More people can develop apps than ever before. There are a lot of different platforms. There are a lot of different ways to build something new, and it's exciting, and people do it, and then they don't realize that they accidentally published a token, and so they frantically Google, how do I remove this? And maybe you don't realize that it's also in the history, so even if you delete the file, it's still there somewhere, and you have to really thoroughly purge your Git repo if you're going to make sure that that token can't be found. But you also might not realize that by the time you've actually done that, someone else has already found your token and taken it off of GitHub, because there are malicious people on the internet. They exist, and they are running scanners of GitHub searching for Slack tokens. They're searching for AWS credentials. They're searching for passwords, et cetera. And by the time you delete it, it's already been taken by someone. So what we want to do is prevent developers from shooting themselves in the foot. So hence, Bulletproof Shoes, the title of this talk. We don't want the accidental leak of a credential to be catastrophic, to be org ruining, to be a nightmare, and everyone staying up all night rotating tokens and figuring out what's going on. And so that's why we built the token nuker. So I showed that if you search on GitHub, you can find tokens. And so what we built is something that does that. It searches, it finds tokens, and then we nuke them. So we revoke those tokens and make sure that they can't be abused. So an attacker or a malicious individual or organization who's looking around for these tokens can't actually use them, because by the time they found them, we have already found them and invalidated them. So we want to automate all the things. We wanted to build a solution that is both lightweight and also fast, because it's kind of a race against time when you're worried about the threat of losing your tokens, so we needed to be quick. And so we built the token nuker. So the token nuker, at a high level, it's a little app, and it searches GitHub for tokens, and then it hits the Slack web app, and then it revokes those tokens. So there's a bit more complexity to this. We're using GitHub's. So this is how it started also. I'll talk a bit about the evolution. But we wanted something that we could throw together quickly and just have running and working. So we search GitHub for Slack tokens. Then we pull them into a database, and we have a note of what token it was and also what file. And so our database is for caching. We hash the file and token, so if we find it again, or if our search messed up and we have duplicates, we're only trying to revoke something once. And then we have a Slack web app endpoint where we revoke a token. And we have a shared secret between the two services, so you can't be some random person on the internet hitting Slack tokens, revoking them for other users, and causing kind of a mini denial of service for them. So we're caching this so that we can save time, and we're searching as quickly as we can and deleting as quickly as we can. And then once we have found something, once we've found a token that is actually valid, we post into a Slack channel. So we're actually using a webhook, which I mentioned a little earlier in our security tokens burn channel. And it says, hey, found this token at this repo, contacted this email. And so we have a big old channel full of this that keeps growing. Very heavy on the fire emojis. It probably is the largest source of fire emojis in the Slack organization, but it is constantly posting there. So this also provides like a searchable record. So if we need to look into things later, we have a nice little Slack channel that we can do it instead of just querying the database. So a couple of the challenges of this. Primarily customer engagement. So let's say we did this in the naive way. We find a token, we just revoke it. Then all of a sudden, someone says, hey, my app broke, or hey, this token's invalid. Or maybe many people start saying that. They start reaching out to customer experience and saying, like, hey, your APIs are all broken, my app doesn't work. And then our customer experience folks have no idea that the security team is doing this. And then they say, well, we don't know why your token's invalid. Let's try again. Then they publish it again, and then their app breaks, and people start to get frustrated and bang their heads against a wall thinking, why can't I use Slack? This should be easier. So the customer engagement part is not crazy technical, but it requires some wordsmithing. It requires empathetic communication. And so we have to be detailed and say, what happened? What steps have we taken? And we use that channel to coordinate with our own CE organizations so that if a customer reaches out, if a user reaches out and says, hey, I just got this email and I'm a little worried, our folks can look at the channel and say, oh, we found your token on GitHub. We found it somewhere on the internet, and so we revoked it. You don't have to worry. You might want to check your access logs, but I'll show you shortly the modern version of the app, and I think we're about as fast as we could be for deleting tokens. Another concern, rate limiting. So if we're scraping GitHub too fast, or if we're hitting our own API too fast, we have rate limiting on all ends, so we can't just nuke. So sometimes we have to sleep a little bit. This is also good because if someone were to try and do a denial of service attack of this service by uploading like a big file with, I don't know, 1 million fake tokens, we do hit rate limiting. We don't get taken down. We can still have regular functionality and continue deleting and revoking the actual tokens that we need to be concerned with. Concern internally is maybe you introduce a new type of token, so we have changes in the platform over time, and so we coordinate with our API team, our platform team, to make sure that we're keeping all of those in mind. And like I said, you can't just say, hey, you revoked your token. You can't say nothing, because that will be annoying. You can't just say, hey, we revoked your token, because that doesn't give any useful information or anything actionable. So we provide clear reasoning. We say what happened. We want to give people pointers so that they don't do it again, so that they're aware of the issue and that they're aware of what problems could have happened. And we prepare our CE folks on what's coming. So I'm not going to read this whole email notification. We send out a long email to the owner of the token and the owner of the organization, and we say, hey, here's what happened. We have some helpful information for you. Please reach out if you have more questions. And that brings me to the evolution, so where we are today. So when we first spun it up, we were looking for a quick solution. We just spun up a server in the Slack infrastructure, and it wasn't really like we had to manually update stuff. We were just working as quickly as we could, but we've reached a point now where we're like, within legit infrastructure, automatically updating, it's more resilient, it's easier to provision, and easier to get people onboarded as we expand functionality. We added a new token that we have, and one thing that I think is super exciting is GitHub has a beta feature for this exact functionality. So they have a token or credential alert process, and we are one of those tokens. So GitHub will search both public repos, and if a private repo becomes public, they will search for regular expressions that we've provided, and then they will send a message over to Slack saying, hey, we found this token. So currently beta, it works with AWS, a couple other credentials as well, and then GitHub sends this notification to Slack. And what this looks like is basically the same architecture, except now our token nuker server is also receiving inputs from GitHub. And those are signed, so we prevent someone pretending to be GitHub and saying, like, hey, look, I found all these tokens. Not that, I mean, if you already had someone's tokens, it would be kind of annoying or a waste of time to send them to Slack to invalidate, because you might as well just do bad things with them. But we do sign them. So we receive those events. And I'm going to show a very cool graph in a little bit about how that has changed how well our search does compared to how well GitHub notifications are doing. So I talked a bit about webhooks. Incoming webhooks are the simplest and most powerful way to post a message to a channel. So really easy. You can do a post request. You can do just curl and say, hey, send this in. Powerful, simple, straightforward. But what could go wrong here? So with tokens, you can lose a lot of information. They're very, very powerful. With a webhook, it's more the content that you can inject. So you could impersonate an app. You could impersonate a user. You can try for phishing and social engineering, spam, things like that. But not quite as bad as tokens, but still not something that we want lying around. So if we do a quick search on GitHub for hooks.slack.com/services, we see 52-ish thousand results. This looks a little worse than it is. We've actually done a deeper dive, and so at first glance, this is pretty bad. But there are a lot of instances where this is just documentation, or they're not valid webhooks, or they're kind of filler webhooks. So the number of valid webhooks is much lower. But we might as well nuke them. We have a token nuker. It's built for nuking things. It's built for revoking things. Let's throw some webhooks in there. So this is something we're working on right now, currently in beta. We had to make some tweaks. So we already had existing functionality in the app for revoking and rotating tokens. We do have that for webhooks as well, but we had to plug them in a little bit more. So we're working on that, and we're working on the communications. So now I'm going to talk a little bit about the feedback we've received and the lessons we've learned through this process. So here's our history of nuke tokens. So we can see this is monthly, so it's 400-ish tokens per month that we nuked. When we first launched it, there's a big spike because we went from 0 to all tokens that we could find on GitHub. That is not in this picture, so there's like one day where it's just like, a bunch of tokens nuked. But here's a more steady flow. We had like a little spike towards the end of 2018, people getting ready for the holidays by publishing tokens on GitHub. And so we see here, though, this is split up over how we find those tokens. So we have two means of fetching tokens. We have the regular search, which is how we started, and we have the information that GitHub gives us. And the great thing about that is you see, like, once we launched that, it just became the main source of those tokens. And if a token has already been invalidated, we don't nuke it. So these data points are only tokens that were valid that we nuked. And that means GitHub is faster. That means we receive a notification from GitHub and we nuke that token. And by the time we search it and find it, it's already been invalidated because we did that. So we're working faster in almost every case with GitHub. There are a couple little blips there, but the vast majority of the tokens we're nuking now are coming courtesy of that GitHub beta feature. And then this is for more current information. Now the vast majority of our tokens are found by GitHub as opposed to search. So the first source of a token is GitHub and their beta feature as opposed to the search that we're performing. Another interesting data point is the number of tokens we're finding that are actually valid. So this is just tokens, not webhooks, but about 80% of the tokens we see are actually valid. So any token that matches the regular expression, we test and we try and invalidate. And if it's already invalid, we just make a note like, hey, this is invalid. So on the first attempt at that, 80% of those tokens are valid. So this is a legitimate concern. It is something that we want our users to be looking out for, but it's also something we want to be protecting them from. Another interesting metric, we grouped by team. So you can see at the very top, there is one team that had 19 total different tokens revoked. We didn't look further into that. It could just be a test team. It could be a team that's using bad test practices and putting their test tokens on GitHub. For the most part, though, we see a very long tail of 1. So most teams only have it happen once. And that's, 0 times is great, and 1 time is the next best level of greatness. It means you don't repeat your mistake. So if this happens to a team once, in general, they're not coming back and doing it again. So sometimes maybe it was a fluke. Sometimes we have teams that have actually benefited from our messaging and from us informing them. So one of our customer quotes is, just wanted to thank you. It's a nice service. I like it. That's great to get good feedback on a service of ours that's deleting a token of theirs and possibly breaking an integration. That's great feedback. In general, we've found that with our communication, people are able to respond to it and not be freaked out, not be too worried, and move on with their lives and follow good development practices. Franz Rosen from Detectify, he's a security researcher. He first started talking with this about us back in 2016. So that was a big impetus for this project. We kind of knew it was an issue. There's just general knowledge that people are leaking tokens, that people on Slack are leaking tokens, but Franz Rosen really put it into perspective for us, like the scope of the problems and the scope of the issues, and so we coordinated with him. We've also been talking with him about webhooks. Webhooks are a teeny bit trickier, and they're less dangerous than tokens, but we're working on this, and we'll be doing that soon. One other note is we're working on translating these messages. So we had an interesting little incident recently where we sent the communication out, and it was a Japanese customer, and they reached out to customer support saying, like, And this exchange was in Japanese, and they were saying, what does this mean? We don't understand this. Slack supports multiple languages, so our emails have to support multiple languages too. We're working on that translation, so not a super technical thing, but it makes it more accessible to everyone. So right now the emails are just in English, but if English is not your native language and you're reading about this, it may not be super helpful. So working on that. We do have a couple features that also can protect against this. We have IP whitelisting, so you can configure your app so that it is only allowed to communicate from certain IPs. Admin approved apps, so you can make it so that only certain apps are able to be approved by your administrators. Audit logs API is a feature that lets you see where app requests are coming from. But these are kind of things that could be used to either prevent an attack if it happens or to have some information about it after the fact. But what we really want to do is prevent it. And so with our token nuker, our goal is that this just never happens, that we've nuked it, we've revoked a token before an attacker could even use it. So friendly reminders and takeaways from this talk: don't put your secrets in a public repo. Whether they're Slack or not, if they're Slack, we'll nuke them. If they're AWS, we won't. Amazon might. If there are other credentials, there's only so much we can do to prevent you from shooting yourself in the foot. With Slack tokens, we're doing our best. Use vaults, config files, use getignore. Don't put like config.yaml or something and upload it, and it's full of tokens and passwords, etc. Add linting rules to catch your tokens. So for Slack, they're pretty easy. It's like XOXP, XOXB, XOXS, possibly just XOX anything, depending on if you're writing XOXO a lot in your code. Maybe you're having a romantic moment with coworkers or something. But another handy tool is BFG Repo Cleaner. So this is something that will help you clean out your repos. So like I said, if you just delete the file, that's not enough. There's Git history there. There are tokens logged. And with that, thank you. We have a Slack booth here in the expo, and we have a bunch of people from the platform team to talk more about like tools, apps, etc., general Slack development. We're also launching Slack communities, so community meetups, things like that. And we have an app, like a platform conference for Slack coming up. So there's more information on that at the booth. And so with that, I don't think we have time for questions, but I'll be around. So thank you, everyone.